Hey, hi. My first calculus class as we are on virtual school now. I just wanted to say hello and welcome. We have a lot to cover. I'm going to try to make this short. I'm going to try to make this sweet and as painless as possible. But I just want you all to know that I miss each of you, and I am picturing your faces in my classroom right now. You're not here, and this is very weird for me, but we're going to get through it. And I hope you can't hear that pounding outside. They are doing crazy construction, just so you know. But, hello, welcome. We are going to go on. So, and I'm writing with a pen, so I probably will mess up. It's okay, right? But we're going to begin lesson 31, the product rule. We have probably two of the biggest topics in calculus coming up, and we aren't even together to go over them. So, as we learn about the product rule, the first thing we're going to talk about is some review. Okay? So as we review, we're going to talk about derivatives because the product rule is all about derivatives. First, if y equals 5x squared, what is y prime? I know you all said it is 10x. We have to remember these rules. If y equals e to the x, yes, Justin, what is y prime? It is e to the x. Okay. What if f of x equals sine x? What is f prime of x? Yeah, Ryan, can you do this without looking back at your notes? It's okay. It's been a while for all of us. I'm going to scroll a little bit. What is the derivative of sine x? It is cosine x. What if y equals cosine x? What is dy dx? Remember, that's just another way to write the derivative. What is the derivative of cosine x? Yeah, it is negative sine x. Another one that we need to remember is what if f of x equals natural log x? Sometimes I'll put those absolute values around it. What is the derivative of natural log x? What is f prime? Yep, it is 1 over x, whatever x is. All right, so that is a little bit of review so that we can move on to the product rule. Now, if you have any of these that we've put up here and we add them together or we subtract them, we simply add or subtract the derivatives of each of the pieces, okay? But it's going to be different with the product rule. If we want to read word for word what the product rule says, you can find it on page 169 in your book. It says the derivative of a product of two functions equals the first function times the derivative of the second, plus the second function times the derivative of the first. I never remember that. Of course, I have a little shortcut. Okay, it's in your book somewhere. You will see it says first d second. I'm going to go ahead and write second like this. Plus second d first. Okay, that means we're going to put the first function times the derivative. This means the derivative of the second function. And then we're going to add the second plus the derivative of the first. Okay, so I'll say this little phrase, first d second plus second d first, a lot. But we need to probably look at what does it actually mean. Okay? I like to signify what is the first and what is the second. Okay? So if y equals x squared sine x, Okay, do you see that there's a function, x squared, times another function, sine x? Okay, so I like to specify which is my first and which is my second. In calculus, we will use u's and v's. U is always my first, so if u equals x squared, then what is the derivative du dx? What is the derivative of x squared? Yeah, it's 2x. So this is my u. What is my second function? I like to call it v. In calculus, we will use the u and the v a lot. Our second function is sine x. What is the derivative of sine x? What is dv dx? You could write u prime or v prime. Quite okay. Derivative of sine is cosine x. So we have a u times v. Maybe I'll write that above. Okay. So we have a u times v. Now, can you find y prime? Okay. Using our product rule, first times the derivative of the second. What is our first function? Is x squared. Our first, so I'm going to write first, then our first function is x squared. Okay, then what is the derivative of the second function? Okay, so we're going to have our d second. What's the derivative of the second function? It's cosine x. And then we have a plus. Okay, plus second. What's our second function? V, which is what? I just circled it is sine x. And then what is the derivative of the first function? Second, d first. The derivative of our first function is 2x. So can you see we have first, d second, plus second, d first. Okay? And yeah, it looks a lot more complicated because we have multiple products going on here. Okay? But that's the product rule. First d second plus second d first. Can you say that with me? Yeah, everybody? First d second plus second d first. All right, let's look at another example. Okay? Let's let f of x equal x squared e to the x. Can you find f prime of x? I'm going to tell you a little secret. Every time I'm going to lay out on the side what my u and my v is, what my first function is and what my second function is. I promise it will come in very, very handy because these will get harder. Lay out what is my u. What is my first function? Everybody see it there? It's x squared. What's the derivative of x squared? This time I'm going to write u prime is 2x. What's my second? What's my v? You see it? It's e to the x. What is my v prime? Yeah, the derivative of e to the x is always going to be e to the x. All right. So, first, d second. I'm going to write this again. First, d second plus second, d first. I'm going to write it as many times as it takes to get it in my head. Maybe to get it into your head. Okay? So, my first is x squared. So, my f prime of x. We're doing the derivative. So, first, d second e to the x plus my second e to the x, there's my x, times the derivative of the first. Okay? Now the question is, can we rewrite this sometimes to simplify it? Okay? We have two pieces, two terms. Is there something common in both? Yes, there is. Does everyone see an e to the x? Ooh, technically there's an x also in each one, so we could pull out an x and an e to the x, and we just have left an x plus 2. Just another way f prime could be written. Okay? So let's look at a generalization of how we could write first d second. So if you want to look at the derivative of a u times v with respect to x. So this is just the derivative of a product. So what is my first? It is u. Okay, my first term is u times the derivative, which would be dv dx. So that's first d second plus second times the derivative of the first. Okay? Or technically this could be written as uv prime. So we would look at the first times the derivative of the second plus the second times the derivative of the first. I like to put the little dots in between just so I can tell the difference. Okay? Two different notations. Two notations for the product rule. Okay? So this is my first, this is my second. All right, let's look at a few more examples. I've got lots here. All right. What about, let's let u equal natural log x and v equal 2 e to the x. And y equals uv. Okay, so there's just another way to write this. Can you find y prime? So they've already told you what u and v are. So, well, if they've already labeled u as this, can you simply find u prime? What's the derivative of natural log x? Now, I hope you wrote down those reviews or you've got them in your brain already. It is 1 over x. And what about the derivative of v? What is v prime? What's the derivative of 2 times e to the x? Well, you might ask, is that a product? No. 2 is a constant and it's never a separate function. Okay? So with every e to the x, the derivative just stays the same. Okay? So we have a first. Let's undo that. I don't like how that looks. So we have a first, a second, a derivative of the first, a d first, and a d derivative of a second. That's another way to look at it. So what is y prime? Will equal what? First, what is your first? Natural log x times the derivative of the second plus second times the derivative of the first. Okay? That's your answer. That's it. Could we rewrite it since we have the same terms? Of course we can. Or it can be written as 2e to the x, parentheses, natural log x plus 1 over x. These two things say the same thing. All right? Are you getting the hang of this? I hope so. If not, you can ask me questions in the classroom. All right, we're going to try another one. We have several examples. And then you can do some on your own. Let f of x equal e to the x cosine x. Can you determine f prime of 1.2? So now I'm not only asking you to take the derivative, but I'm asking you to plug in 1.2 when you get to the end. Does everybody notice there's a cosine in this? And a 1.2. Does that mean it needs to be in degrees? Is there a degree sign there? No. So what should your calculator be in? In radian mode. Yes. So I'm going to go across. I'm always going to do this. I'm going to write my u and my v. So what is the u? E to the x. What is my second function? It's cosine x. What is the derivative of u? What's the derivative of e to the x? Simply e to the x. What's my derivative of v? What's the derivative of cosine? That's right, it is negative sine. So it's easy to write the derivative now that we have our pieces. So f prime of x is simply first, which is e to the x, times the derivative of the second, which is negative sine x. See, I use some parentheses because I don't want that negative, you thinking that it's a subtraction sign, because it's not. Okay? Plus the second, which is cosine x, times the derivative of the first. So I'm going to rewrite just a little bit. And you technically could factor out the e to the x, but I don't know why, but I didn't. That's okay. But I don't like this negative sign being in the middle. So I'm going to say it's times a negative. So I put the negative out front. Negative e to the x sine x plus e to the x cosine x. Okay? And then I'm going to say, well, wait, is this the problem I needed? No. We need to plug in that 1.2. So what is f prime of 1.2? So what do? We simply plug it in. Negative e raised to the 1.2 times sine of 1.2 plus e to the 1.2 times cosine of 1.2. So we're simply just plugging in 1.2 everywhere we see an x. Once you plug that in your calculator, as long as you're in radian mode, you should get an answer. It should be approximately negative. Well, if you didn't put the negative sign, make sure that you did. 1.8914. Okay. Are you good? Is that what you got? You just plug in that number. Okay, I told you I was going to keep these short and sweet. And that's all we're going to do. If you have your books, we're going to do some problems. So only dealing with the product rule, we're just going to have 3 problems tonight, today, wherever you're doing this, in your pajamas, from lesson 31. And this one is just going to be 3, 4, and 5. Okay, we're just going to do the problems 3, 4, and 5 before tomorrow. Okay? If you don't have your book yet, I'll go ahead and give you what those problems look like. Number 3 says, find y prime where y equals x cubed e to the x. Number 4 says find dy dx where y equals negative 3t cosine t. We can use different variables, and you know what I forgot? I immediately wrote dy dx, but it should be with dy dt. I get crazy like that, you know. But I see it. Number 5 says evaluate. Evaluate f prime of negative 2 for f of x equals x squared natural log, ooh, that doesn't look like a natural log, absolute value of x. Okay, so you should have these 3 examples where we've worked out in this lesson to be able to do these problems. Now, I would like you to go ahead and do them and figure out a way to turn them in, whether you do it on Google Docs or if you take a picture of these 3 problems, but I would like to see your work. I'd like to see where you've written u and v, found their derivatives, and then done the product rule. That would make me so happy, and we'll come back tomorrow. Bye.